Hello everyone, I'm gonna present our demo on routine calculation problem with quantum computing, and we have a web application here. On the right side we have map and result section, and the left side we have some settings buttons. And to be able to start our optimization we need some data to rely on. So this data directly comes from the open data portal of City of Antwerp, and there are around like 500 data points here. And as an example we can use glass container data. And each data set has some CSV file format as a downloadable format, so a user can easily download the data to their local computer, and then go back to the our web application, and then there we can select the data directly, and then it automatically translates that data to our environment. And in our environment we uses some OpenStreetMap data, and it includes it's not dynamic data, it's default values, but it is a place to start on. So we have some street data, the maximum speed or the trucks are allowed to drive here or not, and also in future dynamic data can be integrated here. So for example, if there's an accident at that street and it's closed, we can also include in our optimization problems. And besides those data points, we also have our locations that comes from the CSV file, and those objects has some ID numbers and the names, and this also comes from the CSV file. And also we have some resources here, R1, R2 and R3. These are default values right now, but in future they can be also dynamic data. For example, for glass container data, R1 can be the the glass like kilo, or the number of the fulfillment in the container data. And the optimization problem runs on these resource allocations as well. So after we see the data sets, we can go to the optimization part. And for the optimization problem, also we can change our data sets here. For example, like this was the glass container data, and here is another data set runs on the bicycles. And for our optimization problem, we can define our vehicle type. This can be truck or delivery drones. Truck drives around the streets, and delivery drones calculates the flying distance from the instance to another instance. And we can also define our vehicle number to deploy, like we have the central depot location, and then there, for example, can up to 10 vehicle be deployed here. So we can stay with one for the first example. And then we can also change the distance around the center point. So if we increase that point, we will see more points, more far points also included in the graph. And also if we changes the location number, it reads more on the CSV file, and then there will be more locations to deploy on the map. But for our the first problem, we can decrease the number of the instances to run in an easier way. Like for example, increase the bit more. So here we have a data, and also we can choose our solver type, and there are like 4 examples here, but we can run on 2 right now. And we can also define a solver time limit, maximum time limit that a solver can take. So for example, we can run this problem on a classical machine learning algorithm, which is k-means. Here we have solution, and we can see the solution. Here we have our depot, and it travels around the distances, and it shows which location to go first and their lines. And also on the result section, we can see the total distance and the locations and the resources for that vehicle. And also we can see the problem details, how much time it takes, and the location numbers, the problem size. And then once we go back to our settings, we can run the same example for D-Wave machines. We have a solution, and now it's the same problem, but it runs on a D-Wave's quantum annealer, which is located on a cloud-based computing. And then we can compare the results we define the time limit as a 10 second, and D-Wave quantum annealing hybrid result is overcome the classical one, and there's around like 3-4 kilometer difference between the distances. So D-Wave calculated in an like an efficient way the distances, so it can save us some time and also energy. And for example, we can run a example for different, for example, like vehicle number. The example, now we have a bit different map, but this shows like there are different vehicles deployed from the same location, and then there are other routes of each, and then on the results section we can see each vehicle, how much distance they have and how much resources they got on the example. And then also I can show you another run with the delivery drones, for example. And yeah, as I said, the delivery drones calculates the flying distance over time. And as a conclusion, we showcase here how a quantum computer can have an implementation on the routing calculation problem, especially for city of Antwerp. Now we have some default, like some parameters that can be further developed, even more settings. Like for example, we can focus on other vehicle types and maybe more dynamic routing problems that also integrates the real-time data. Also like the integration for the resources in the locations that we're gonna like deploy our cars on. And also we can define some other problems where we have multiple central points. So but this showcases how quantum algorithms can decreases the excessive times on optimization problems.